Okay guys, another day of some more word problems. These word problems might have a little bit more steps in them, or thinking through a diagram or thinking how to solve them might take a little bit more time now that we've done some of the simpler ones. That being said, 17 from homework was not simple, I know that. First question, actually it doesn't change. First thing you want to do is to try to draw a diagram. So I'd pause the video here, read the question, read it once, get a visual of what's happening, then read it again and draw a diagram. Don't draw the diagram until you've read the question through one full time. Pause the video, resume it once you have the diagram drawn. Okay. Does your diagram look something like this? So you have the camera on top of a building. So here's the camera right here. Right? It's on top of a building that's 120 meters. When it faces the bottom of the next building, so that tells me I have another building over here. When it looks to the bottom, so when it looks down here, it makes an angle of depression. Angle of depression is from a horizontal line going down. So that's why the 36 is in there. It has an angle of elevation when it looks to the top. So if you have to look up to see the top of something, it's obviously going to be taller than you. So this line would go up. Angle of elevation from the same horizontal line going up. What it wants us to do is to find out how tall the other building is. Well, I have to problem solve my way a little bit through this. So I want to find out the height of this building. What I know is that this bottom portion is 120 meters. Right? Because if the camera looked directly across, it would be the same height. So what I need to find is this extra portion. The trouble with that, if I look at this top triangle here, from 45 degrees, that X is the opposite side. I don't have enough information to do anything with trig. If I said sine of 47, I would have the unknown over a hypotenuse, which I don't know. If I tried tan of 47, that would be the opposite over the adjacent. I don't know either of those things, right? If I have one equation, there can only be one thing I don't know. So look at the diagram. Do you think we could find out the hypotenuse? Or do you think we can find out the adjacent side? Hopefully, you thought that you could find the adjacent side. I'm just going to delete this stuff. You can find, you can find the adjacent side. Let me do the adjacent side in pink. You can find the adjacent side using this bottom right triangle. Right? Because from 36 degrees, 120 is the opposite. I don't know the adjacent. O and A. SOH CAH TOA. SOH CAH TOA. It tells me to use tan. So tan of 36 degrees is the opposite 120 over the adjacent side. You can flip those, so the adjacent side would be equal to 120 divided by the tan of 36 degrees. And when you go to your calculator, the adjacent side is approximately 165.2. Great. Now if I go back to that green triangle, let me change green, probably see this bright green better. If I go back to that green triangle, I now know the adjacent side. So I can now go back to that tan of 47 degrees equals X over the adjacent side, which is 165.2. To get X, you bring that 165.2 up and multiply it by the tan of 47 degrees. X is approximately 177, you could say 0.1. It doesn't tell you how to round, so as long as you round correctly, I'm good with that. So now careful. The height of the building is not 177.1 meters. The height of X is 177.1. The total height of that building then is those two numbers put together. Don't forget your therefore sentence. Therefore, the second building is 297.1 meters tall. So you can see how there was like a little bit more steps, a little bit more thinking involved. Not all word problems are the same level of difficulty, right? So some of them can have more steps and be more difficult. Something else I want to talk about is the concept of directions. Trigonometry is used a lot in navigation type problems. So we're going to see questions that relate to bearings. Bearings are directions, right? So you need to remember or need to know some stuff from grade 9 geography, that north and south. Due north we think as like straight up, due south straight down, and then east is kind of to the right on a diagram, west in terms of a diagram is to the left. Okay. So however you remember those, I'm not sure if it's the cardinal points or the ordinal points, but however you remember those directions, make sure you jot that little symbol down because it's going to help you a lot. So if something said you are going due east, due south, due north, due west, that means you're going in one of those directions. So due east, I'd be starting here and going straight to the east. Due south would be from this, like from a point going straight down. Okay, so I think you get the idea. The trouble is we don't often go due south, due north, due east, due west. We often go somewhere in the middle. So let's look at line A here. That line A is going, let's get to red, is going, it's not going north, it's not going east. It's going a combination of northeast. All right. Exactly northeast would be 45. It'd be right in the middle of the two, but we're not. So how we can describe this direction is a couple ways. In words, it might be written as something like this: 30 degrees east of north. Right? And then you can see it's east of north because I'm measuring it from north. Here is due north, but I'm going 30 degrees towards the east. A shorter way of writing that exact same sentence would be to say north, then 30 degrees to the east. Oops. All right, so if I see something like this, I will instantly jot down, okay, here's north, and I'm going 30 degrees towards the east. You could also express it, it's not as common. You could also say like this angle is 90, so from here to here is 60. And that you could say 60 degrees north of east, or east 60 degrees north. This one we don't ever see, right? Whenever we see them written shorthand, it's always north or south first. Okay. So that's the first one. Look to C and think, okay, what's the general direction of that line? It's not south, it's not east, it's somewhere in between south and east. This would be due south, right? We're not going due south. Instead of going due south, we're actually going 70 degrees towards the east. So you would write it this way. In words, you could say 70 degrees east of south. Okay. Two more, and if you want to pause the video, try to think how you would write this direction for D and this direction for B. If you're looking at D, it's going 80 degrees west of south. So from due south, it's going 80 degrees towards the west. Line B, that yellow line, from north, we're going 60 degrees to the west. Okay. So let's put this into a problem now. A car leaves its parking spot at a bearing of south 20 degrees west. After traveling for 2 hours at 35 kilometers an hour, how far west has it traveled? This is where I would quickly jot down north, south, east, west, just so you don't forget those. Pause the video, try to draw this diagram. Okay, so here's the diagram I came up with. This is the car. Oops, let me use a color we can see a bit better maybe. Green showed up nicely. Here's the car right here. And it's traveling southwest. North, south, east, west. So it's going in that direction, between south and west. So it's traveling this direction. First thing I had to do is figure out the distance it was going. So I took the speed the car was traveling, multiplied how long it traveled for to get the 70. And then this south 20 degrees west. That means 20 degrees west of south. This line here is my due south. I'm going 20 degrees towards the west. So the 20 degrees goes in that angle there. How far west has it traveled? Well, okay, now we've got everything there. So we're going to label the sides and then according to SOH CAH TOA decide which ratio I use. From 20 degrees, x is the opposite, 70 is the hypotenuse, opposite and hypotenuse is sine. So sine of the angle equals opposite over hypotenuse. Bring that up and multiply it. Again, it doesn't say how to round, so you round however you want, as long as you round correctly. Approximately, I've got 23.9. So therefore, the car has traveled 23.9 kilometers west. Okay. So there's those directions. Example 3. This is like 17 from the homework. So Sam and Tina are standing 21 meters apart, and looking up they see a bird between them. If Sam looks up at an angle of elevation of 34 degrees, Tina looks up at an angle of 19 degrees, how high up is the bird? It's kind of like the tree, right? You had people on either side of the tree. Here it's people on either side of the bird. How tall is the tree? How high up is the bird? So very, very similar problem. I will walk through a solution, but first try to draw this. Pause the video, draw out what you know. Okay. Does your diagram look something like this? We're going to ignore, nothing in here says how high Sam is, and nothing says how tall Sam or Tina are. So we're just going to ignore that. And we're going to just kind of extend this like this, just like that tree question yesterday. And what we want to find is this. I'm going to show you another way to look at it. So exact same drawing, but because we don't know how to solve non-right triangles, I need to break this into two right triangles. So I've got the purple one and I've got the green one. They both have the same height, so I use the same letter, x, because the height of that bird is the same in both triangles, so I can use the same letter for it. Then all I know is the distance between the two girls is 21. I don't know how far either one of the girls are, so what I did is I let y represent one side, then the other side would be 21 minus y. Right, because that bottom side has to add to 21. Y plus 21 minus y does equal 21. Okay, so we've seen that concept come up in this course a few times now. From each of those triangles, so from the purple triangle, the sides that I'm working with are the opposite and the adjacent. Same thing in the green triangle, opposite and adjacent. So I wrote down tan equations for both, and you can see in both of them, there's two things I don't know. But that's exactly what our unit 1 was. Two equations, two unknowns. We can solve them with substitution. So what I'm going to do is I'm going to rearrange these equations. I'm going to bring this y up to say that this equation, y times tan 34 equals x. Same thing here, I'm going to bring this up, but there's two terms here. 21 minus y, all multiplied by tan 19 degrees, equals x. I'm going to keep this in exact values. It would be okay if you switched to decimals this year, but just to keep my answer exact. So I'm just going to do one more thing with this green equation. I'm just going to, actually no, I'll hold off on doing that thing. Both of these equations now equal x. So I've isolated x, I can do substitution. I can say that y times tan of 34 degrees equals 21 minus y times tan of 19 degrees. Okay, I'm solving an equation. I want to get y by itself. I've got a y term here and a y term here. Tan 34, tan 19, those are numbers, right? They're stored in our calculator as really long decimals. I'll go to my calculator at the end. You could, if these questions really challenge you, you could change this to a decimal right now. And what do we get? Tan of 34. You could say that this side is approximately 0.675 y's. I don't want to, I want to keep it exact, but you could do that, and then you would just work with this as the coefficient, just like you did in grade 9. Instead of doing that, I am going to keep this exact, and you can see how I will do that. First thing I want to do is distribute this, so do 21 multiplied by tan of 19 degrees minus y times tan of 19 degrees. In this whole equation, I have three terms, right? Oops. This is one term, this is a second term, and this is a third term. This big messy term is just a number, right? 21 times tan of 19 will give me a number. But this purple term and this last green term both have y's. So what I'm going to do is I'm going to bring that term over. And I'm just going to switch to black now, just to do all my math in black. So y times tan 34, I'm keeping there. I'm going to bring the minus y tan 19 over, so it becomes plus y times tan of 19 degrees. And the 21 tan 19 stayed here. The reason I did that is I now have both of my y terms over here. Kind of like if you were solving an equation, you'd get x's on one side. What I can do is I can common factor a y from both of these terms. If I divide the first term by y, I'm left with tan of 34. Divide the second term by y, I'm left with tan of 19 degrees. And now to get y by itself, all I would have to do is to divide out all of this stuff. If need be, maybe pause the video right here and just look and say, wait, what did she do? Take a minute to look over it and process it. Now, just be careful. This is a big calculation on my calculator. So I've got 21 times tan 19 for my numerator. And now I need to divide my denominator. I would use brackets on your calculator. So divide that by tan 34 plus tan 19. It equals, and I have that y is approximately 7.1 meters. If you look back to the question, and I do this a lot, and I say, oh, the bird's 7.1 meters up in the air. The height of the bird was not y. The height of the bird was x. In order to find x, it's just like we did with substitution. You take your answer, so we'll take this 7.1 and sub it into either equation. You could sub it into the purple stuff, or you could sub it into the green stuff. Purple looks a lot easier. All right, so I'm going to take that 7.1 and I'm going to sub it into the equation y times tan 34 degrees equals x. .1 times tan 34, oops, that's wrong. I get the height of the bird to be approximately 4.8 meters. So again, if you need to, just pause the video here, look over those steps until you understand. One last question, and this question's not hard, but a lot of trigonometry comes down to a visual thing. This question says find the area of the triangle. Well, we know the area of a triangle is base times height divided by 2. And when you see a triangle this way, we want to say that this is the base and this is the height, right? Because we want to put the base at the bottom. I don't actually want to do that this time because I don't know BC. I know how long AC is or how long AB is. So why don't I just do that? Why don't I make this side the base? Oh, okay, so then I can say the base is 7.6. The height would be something close to this, right? So perpendicular to the bottom and going to point C. That's the height. I don't know the height, but the height of something is always part of a 90-degree angle. So if I look to this right triangle now, this is my reference angle. 6.7 is across from that 90-degree angle, so that's the hypotenuse. The height that I'm looking for is the opposite side. Opposite and hypotenuse is sine. So I can do sine of 28 degrees can equal the opposite side over the hypotenuse. Bring that up and multiply it. And you get the height is approximately 3.1 units. I don't know if it's centimeters or whatnot. So now I can put that into the area formula. .6 times 3.1 divided by 2. The area of that triangle is 11.78 units square. Okay. So if you get a question like this, don't always assume the base is at the bottom. See, can you make it simpler on yourself and maybe like visually rotate that triangle in your head? All right, that is it for word problems. Now I'd like you to finish up any questions from yesterday you didn't understand, and then work on the handout. Okay, the solutions are linked on my website.